Chapter 8, Curve Fitting. So in this chapter, we will learn several methods to do curve fitting. The first section is linear regression. Okay. So this is we use a straight line to feed the data. Okay. So this week we just finished the first section. So now there are a set of n data points. So xy, x1, y1, x2, y2 until yn. Now we need to find a straight line. So y equals c1 plus c2x. c1 offset, c2 is the slope, right? And that the straight line is closest to this point. Okay. So here we define d, capital D, as the sum of the square errors between the approximating line and the data. Okay. So d equals sum. So I equals 1 to n. yi equals yx. So this is from this formula. This one. Then square. So we know inside square brackets, this is the difference between the original data and the data from the formula. Okay. This difference could be positive or negative, right? After square, then becomes positive. Add all together, so we get the positive. Then substitute this formula in, so that's yi minus c1 plus c2 xi. Then expand this one, so we get this the sum of this square. In this formula, we do the partial derivative. If d is the minimum, then this means partial d by partial c1 equals 0, and also partial d over partial c2 equals 0. Okay. Then we just do differential with this formula. Okay. So partial d over partial c1, then go to this formula, then sum I equals 1 to n square, then we go to 2 times yi minus c1 plus c2x. Right. Then for c1, that's minus 1 equals 0. We said before, this partial derivative should be 0. Then 2 times minus 1, that's the minus 2. Constant, that's cancel out. 0 divided 2 minus 2 is 0. So we can get D. So I equals sum I equals 1 to n yi minus c2 I sum I equals 1 to n xi minus n c1 equals 0. Move these two terms to the right side, so we can get D. So n c1 plus sum I equals n I to n xi c2 equals sum I equals 1 to n yi. So this is equation in here. C1, C2 are variables. Okay. So then we know n, these two sums are constant, right? This is from the data. They are just the constant. Similarly, partial d by the partial c2 still do differential with this formula. Now c2 is the one. So sum I equals 1 to 2 yi minus c1 plus c2 xi is the same. Then for c2, then minus xi equals 0. Similarly, 1 minus 1 times 2 minus 2, we can cancel out. Then we can get this one. So first one, sum I equals 1 to n xi times yi. Then minus c1 sum I equals 1 to n xi minus c2 sum I equals 1 to n xy squared equals 0. Similarly, move these two terms to the right side. So again, so these three sums are constant. They are from the original phase. Then equation 1, equation 2, C1, C2 are variables. So this is the linear equation. Solve these linear equations so we can get the solution C1, C2. For this C2, you can find the line. So their denominator are the same. Just the numerator is different. So C1 sum yi times sum xy square minus sum xi times the sum xi over n times sum xy square minus sum xi. C2 similar. So we will use these two formulas to get the C1 and C2 as offset slope. The mark. This method we call is the linear least square. So this is the algorithm name. Also we call this is linear regression. Okay, so now in this example, okay, so now clear all, close all, COC. So now XY, X, so 2.3, 3.1, 4.6, 5.2, 6.5. Y, 6.1, 9.8, 15.2, 16.1, 20.2. So 1, 2, 3, 4, 5. So 5, 4. Then we need to get the length of x. So n equals length of x, so it's 5. Then first use get the sum of x. Okay, so x is x and y column vector. Okay. So x, so I use x because we cannot type sum symbol here. So I use x. So equals sum x. Similarly, xy equals sum y, then x squared sum. The sum of x squared, so sx2, 2 for square, equals sum x dot carrot 2. Dot carrot 2, so this is the square for elements of the x. Then sum of the xy, so sxy equals sum x dot star, so this for multiplication y, so x dot star y, so this is the elements to the multiplication. Okay. So this from this formula, actually from this formula, so y x sum y sum x square sum x yi. So this is the sum xi again. This is the sum x square. Okay. Then this is the same xi yi x y x square then sum. Okay. Okay. So now we can calculate C1, C2. So here we define C equals 0, 2, comma 1, so column vector 2 rows 1 column. C1 so is equals x sy times x squared minus sx times sy then over n times x squared minus sx times xx. C2 similar, so actually these two just from that two formula. Here again, let me compare this. Oh, actually, put these two together. Okay, now. Okay, so now we can check. Okay, so this is the C1, right? So y x squared sum x squared minus sum x times sum xy here over n times s squared, the minus sum of x squared. C2 similarly, so n times xy sum of the xy minus sum x times sum y over, we said before, denominator are the same, so n times x squared minus sum x squared. Okay, so now we just use this formula. Now we get C1, C2, then XC, YC, this is from the C1, C2. At the beginning, we created the X vector. Okay, so X vector so equals floor minimum X, so this is go down to the closed whole number, minimum X. Then comma 0.01 is step number, column ceiling cell maximum X. So this is round up, okay, to a whole number. So minimum, maximum, then for the YC, so we can get from X with the C1, C2. And for here, YY, this is from the original X. Here, this is 5 point. So YY equals C1 plus C2 times X. Just remember, X just. Then we calculate the mean square as between YY and Y. So this is the original data. So sum YY minus Y start square, then divided by N. Okay. Then plot the first one, we plot XCYC. This is the straight line with 1.2. Then hold on, then plot original data. So X, comma Y, O for the circle, color for red, mark color also for red. So this is the solid square. The mark size just 8. So it's right now. Read on X label, Y label, we used before, title, so linear regression from size 16, the same as before, then side GCA from side 13. Okay. So let me run this one, give you the solution. Okay, I think this is okay. So blue line is the line we get from the calculation C1, C2. The red dot are the original data, the 5 original data. This one, this line is the close, is the line or the minimum error close to this side. So this is the linear regression. Get a straight line approximating to the origin data. Then you can go here, so you can see mean square error, and this is very small, 0.309. Okay, go back here. So this is the example. Then we need to go to the homework. So we have the two homework questions. So first one, similarly, then you use the new data. So x, y, so 1, 2, 3, 4. So 4 points. So actually for first one is very simple. Just replace x and y with the new point. Okay. So you don't need to change others. Then question 2. So this is use a date file xy.map. So this one I already upload to the canvas. It's on the canvas. Let me load this file in MATLAB. Maximize this one. Clear everything first. Okay, so I already uploaded here. So xy, that. Okay, then show workspace. So you can see x, y. So now they are 101 points of x, y. So this is the reason why I cannot type these numbers in the handout. So just use this file. So now you have the 101 point. Similarly, for this one, actually for you don't need these two lines. You just load the file in here. So the others actually we also don't need to change. We always use this formula with C1, C2. Okay, so this is the first section, section 8.1. We need to finish example and 2 homework questions.